Next, very important problem. So find they'll ask dependent source problem and they'll asking find z and y parameters together. It is asked for 10 marks. You have to find z and y parameters for the given network shown. Okay. So you can do for finding z parameters. Okay. You have to apply KVL. So here how many meshes are there? 1, 2, 3. Because I told this is 1. Last one should be 2. And inside we have 2 more. So if you get 4 equation, solving is difficult. So what is the best method is you can convert this current source. Okay, this is a dependent current source. Arrow mark means it's a current source, dependent current source in parallel with 2 ohm. This you can convert into voltage source. So V is equal to IR. Y value is 3I2, R value is 2. So 3I2 into 2 is 6I2. So I can and arrow mark side plus. This arrow mark is down. So downside is plus and minus here. And same 2 ohm you have to rewrite here. So that now you are going to get only 3 equations. Okay. This is I1. I told no in the 2-port network. Input side V1, I1. Output side V2, I2. So I2 direction is left side only in the 2-port network. Remember I refer other problems. So always in 2-port network I1 V1 direction is this, V2 I2 is direction Y. So that's why this you have to call as I2, this as V1. So in between one more mesh is inside that you write I3. Okay, we reduce this 4 meshes to now only 3 meshes by transforming this dependent current source into dependent voltage source. Okay, for always for current source resistance will be parallel, for voltage source resistance will be in series. So this parallel resistance converted into series resistance because now it is a voltage source. Here it is current source, it is a parallel. Now apply KVL for mesh 1. You have to apply KVL for mesh 1. Coming to here, this is plus minus. For this mesh 3, plus minus plus minus. This is a voltage source, minus plus. For I3 current, plus minus. For I2 current, it is fixed. I2 is this side. So plus minus minus plus. Now apply KVL for mesh 1. So V1 is equal to this voltage will be parallel to this parallel voltage. So in this parallel voltage 1 into I1 is coming down, I3 is going up. So it is V1 is equal to 1 into I1 minus I3. 1 into I1 minus I3. We'll write here. Apply KVL for mesh 1. So this is minus to plus no. So minus V1 plus 1 into I1 minus I3 is equal to 0. So V1 is equal to, you minus is there now, you bring it to right side. We left with 1 into I1 minus I3. This is equation number 1. Same thing you are going to get here. V1 is equal to I1 minus I3 into 1. Similarly, apply KVL for mesh 2. Mesh 2 means last, because in 2-port network, V2 I2 is at the end. So if I apply KVL at Kirchhoff voltage law here, it is minus to plus. I am writing KVL for mesh 2 here. So that how you are going to get, you can see now. Apply KVL for mesh 2, or you can tell that this voltage will be equal to voltage across this. So V2 is equal to 2 into I2 is coming down, I3 is also coming down. So 2 into I2 plus I3, and this is a voltage source. It is minus plus, so minus 6I. Understood? This voltage will be equal to this voltage. This voltage V2 is equal to this parallel voltage. In this parallel voltage, two currents are flowing. I2 and I3 both are down. That current multiplied by 2. 2 into I2 plus I3. And it's already voltage source minus 6I. So if I simplify this, 2 into 2 is 4. And sorry, 2 is 2I2 minus 6 I2, which is equal to 4 minus 4 I2. 2 into I3 is 2 I3. So it is minus 4 I2 plus 2 I3. So equation number 1 and 2, if you refer, Z parameter equations are V1 and V2 are expressed in terms of I1 and I2. But here unwanted term is I3. Here also unwanted term is I3. So you have to eliminate I3. How to eliminate I3? You have to apply KVL for mesh 3. Apply KVL for mesh 3. Get expression for I3. Substitute the value of I3. Okay, you are going to get V1 in terms of I1 and I2 only. Similarly, V2 in terms of I1 and I2, so that you can compare with standard equation and you can tell directly the answer. Okay. So now I am applying KVL for mesh 3. In the mesh 3, here you can start from 1 ohm. Okay. So I'm considering plus first I'm getting plus, but the different authors use a different. They are using second minus minus last plus. Now instead of that I'm using plus 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 minus. So I will change here plus, this is plus, this is also plus, this is also plus, this is I'm writing minus, this is I'm writing minus. Now let me write the equation. Both are correct actually. Root multiplied by negative will give the same answer. Okay. Plus, please here, plus 1 into I3 minus I1, because I3 and I1 flowing opposite direction, plus 2 into I3 plus 2 into I2 plus I3, I3 plus I2, because I3 is down, I2 is also down, because in the mesh analysis we are writing clockwise direction for all the meshes, but here in the two port I2 direction is fixed towards the node, so you can write opposite, and both the currents are flowing same direction. So instead of I2 minus I3, please note down it is I2 plus I3, because I2 and I3 both are going downwards only, plus 2 minus, and this is minus first now, so minus 6 I2 is equal to 0. Simplifying this, you get expression for I3. 5 I3 is equal to I1 plus 4 I2. If you simplify this, we'll get the same answer. After that, 5 I3 is this much, means I3 is equal to divided by 5. Now this value of I3 you have to substitute in equation number 1 and so normal procedure what is that is, write expression if you have three meshes, write expression for mesh 1, write expression for mesh 2, you'll get unknown term I3. So in the middle mesh you apply KVL and get expression for I3 alone and substitute that values in first equation and second equation, you are going to get the required solution you are going to get. So I3 value is known. Now substitute the value of I3 here. Okay, substitute the value of I3. You will get V1 is equal to V1 in terms of I1 and I2. 4 by 5 minus 4 by 5. So how to do this calculation, subtraction and all? So 1 minus 1 by 5 is 4 by 5. LCM is 5. 5 minus 1 is 4. So how to do this using calculator? You refer to my previous video. I explained. So now after comparing with standard equation, okay, Z11 is 4 by 5. Z12 is minus 4 by 5. So two parameters are over. Similarly, substitute the value of this I3. Substitute the value of this I3 in equation number 2, where we wrote KVL for mesh 2. And there also, if simplify, you're going to get in terms of I1 and I2 only. So this one is Z21. This is Z22. You have to write all the units as ohms. Okay, all are Z parameters, and its unit is ohms. 4 by 4 minus 4 by 5 ohms. 2 by 5 ohms minus 12 by 5 ohms. So you have to find Y parameters also for this circuit. So you can use a relation between Z and Y parameters. So Y11 is Z22 by, so it is Y11 is equal to Z22 by delta Z. What is delta Z? Delta Z is in Z. This, you have to know the relationship between Y and Z. Y in terms of Z, Y parameters in terms of Z. So this is the original Z matrix. Z matrix determinant is 4 by 5 into minus 12 by 5 minus product of opposite minus 4 by 5 into 2 by 5. If you simplify, you'll get minus 8 by 5. And y11 is z22 by delta z. Z22 is here. By delta z is this. You'll get 3 by 2. Y12 is delta 12 by minus delta 12 by delta z. Delta 12 is this. By delta z is this. Y21 is z21 by delta z. Z21 is 2 by 5. This is minus z21 by delta z. Minus 2 by 5 minus 8 by 5 minus minus get cancelled 1 by 4. 5 will get cancelled, 2 by 8 is 1 by 4, and z22 is z11 by delta z. This is easy, I think. Y11 means z22 you have to take divided by delta z, and y22 is z11 you have to take divided by delta z. And here y12 means simply minus you have to take minus z12 by delta z, and y21 also minus you have to take minus z21 by delta z. So somehow you have to remember this conversion formula, and once you know the z parameters, by using conversion formula you can also write y parameters.